All right, welcome back. We're going to do a couple examples, or a few examples. Let me see, I don't even know how many I got here. A lot of examples. Okay, so first example is we're going to start with dy dx equals y over x plus 2x plus 1. Okay, so the first thing we're going to do here is we're going to try to make it look like the type of equation that we were expecting. Okay, so first, a little algebra magic. dy dx, I'm going to move that y over x to the other side, but I'm going to write it as 1 over x y equals 2x plus 1. Okay, so now my integrating factor, I don't know if you remember, but it depended on this function. So my integrating factor here is actually e to the integral of negative 1 over x dx. Okay? Little careless with the variables, but it'll be all right. So now, what's the integral of negative 1 over x? Well, negative natural log of x. I'm not worried about the constant because the constant would be there on the whole thing. Okay, it would be, because since I'm multiplying by the integrating factor, I would be multiplying by the constant here, here, and here. Okay, little bit more algebra to do. This is going to be e, remember, to the natural log of x to the negative 1. So this simplifies to 1 over x. So my integrating factor, I don't actually need the e in the final expression. Okay, so I'm going to go ahead, I'm going to multiply this whole equation by the integrating factor. So my next term, or my next version of the equation, is 1 over x dy dx minus 1 over x squared y equals 2x plus 1 over x. So far, okay? Awesome. Okay, so now, this was our integrating factor, right? 1 over x. Now we know by the way that the integrating factor works that this thing on this side is the derivative of 1 over x times y. Okay, so this is the derivative of 1 over x times y equals 2x plus 1 over x. You can check that if you want, okay, using just the product rule. So 1 over x times the derivative of y plus y times the derivative of 1 over x. What's the derivative of 1 over x? That's right, it's negative 1 over x squared. Okay, so now we're going to go ahead and do, well, let's do a little simplification, but we'll integrate both sides. This integral is easy. We just get rid of the derivative. Equals the integral of, I'm going to write this as 2 plus 1 over x. What happened there? Sorry about that, my pencil stopped writing. 2 plus 1 over x dx. All I did here was, remember, I canceled here, so 2x over x, and then plus 1 over x. So on this 1 over x times y equals 2x plus natural log of x plus a constant. So y of x equals 2x squared plus x natural log of x plus c times x. Okay, so if you have any questions, go ahead and write them down. All right, and then we can talk about them in the next live session that we attend. All right, let's do another example. Well, first, let me give you the, okay. Another example. Let's take dy dx equals 4x plus natural log of x plus 1. Oh, nope, that was not an example. That was just me checking it. Let's do another example. Let's do xy prime plus 3 y plus x squared equals sine x over x. Okay, so now if you want to check yourself, what you can do is pause the video right now and then give yourself attempt to solve it. Okay, attempt to solve it and then see. Okay, I'm going to give myself like 2 seconds. 1, 2, and I'm going to solve it. All right, you guys back. You solved it, right? Let's see if we did it right. So let's take, and we're going to simplify this a little bit. So we're going to write y prime plus 3 over xy, okay, plus 3x equals sine x over x. I'm going to move that 3x over to the other side. All right. So now, what is my integrating factor? Okay. Integrating factor, I just realized, never mind, we'll think about it later. Integrating factor is e to the integral 3 over x. Okay, so that's going to be e to the 3 natural log of x. Not worried about the constants here. Okay, but that is equal to e to the natural log of x cubed, which is simply x cubed. So x cubed is what I'm going to multiply on both sides of this equation. Okay, multiplying x cubed on both sides, I'm going to get x cubed y prime, plus 3x squared y equals x squared sine x minus 3x to the 4th. Okay. I made a mistake. Let me fix it. So here I had y and I had divided by x, right? I had not divided this one by x. So let me put a squared here. So that becomes x sine x. Okay. I did not want to have to do 2 integration by parts. 1 is okay, but 2, that's just excessive for class. Okay. So now we're going to go ahead. We're going to apply the integrating factor. So we realize that this is the derivative of x cubed y. Okay, So now we're going to take and integrate both sides. Let me see how I'm doing on space. Doing fine. So we integrate both sides. Okay. Left-hand side doesn't really require much, just getting rid of the derivative, or just getting rid of the derivative sign. Right-hand side. Well, I'm going to have to integrate x sine x dx minus the integral of 3x to the 4th is what? 3x to the 5th divided by 5. Let's just add a c in there. Now I'm going to have to do this x sine x. Integration by parts is awesome. I'm just telling myself that. Okay. Remember, when I'm doing integration by parts and I have a polynomial times a trigonometric, I'm always going to let my u be my polynomial. So u equals x. dv equals sine x dx. du equals dx. v equals negative cosine x dx. Nope, no dx on there. Okay, so the integral here is going to be, of course, negative x cosine x minus the integral of v du, so plus cosine x dx. So you're going to get negative x cosine x. Integral of cosine is, of course, sine plus sine x. Okay, so here we get xy x cubed y equals sine x minus x cosine x minus 3x to the 5th over 5 plus c. So y equals 1 over x cubed sine x minus cosine x over x squared minus 3x squared over 5 plus c over x to the 3rd. Okay. All right. Let's go ahead. I'll start a new video soon.